let us see about the different types of fatty acids. So there are two main types of fatty acids, saturated and unsaturated, based on the presence or absence of double bonds. Before getting started, let's also see the structure of any fatty acid molecule, whether it is saturated or unsaturated. Any fatty acid structure will have three parts. So the first is a COOH, an acid group, and then there is a long hydrocarbon chain, and at the end there is a CH3, a methyl molecule. Now if you look at this as well, there is an acid group, then there is a hydrocarbon chain, and then a CH3 group, right? So starting with the saturated fatty acids, if you try to memorize like saturated fatty acids are solid at room temperature, no double bonds, you might remember it at that moment, but later on you might get confused. But if you are understanding the concept behind, it's very easy to understand this as well. Still, if you want to keep in mind saturated S and solid S, so you can remember it that way. Now let us see why saturated fats are solid at room temperature. So there are different types of saturated fatty acids, lauric acid, myristic, stearic acid. For an example, I have taken caprylic acid here, C8H16O2. Sometimes when you are trying to find out the molecular structure of certain compounds, you would see something like this. And then you would just see double bond oxygen atoms. So they are pretty much the same. In order to represent it in a simpler manner, they represent it like this. So each of the ends here represents a carbon atom. Now this represents a carbon atom, this one as well. The starting and the ending, all the peaks here, and this one here represents carbon atom. Each carbon atom is covalently bonded to two hydrogen atoms as well. Now in order to understand it better, I've taken this format. If you look at this structure, there are no double bonds present, right? When it comes to the carbon atoms, that means that all the carbon atoms in the structure are saturated. They cannot bond with any more hydrogen atoms, right? They have already bonded to their maximum capacity. That is why these are called as saturated. Now, because there are no double bonds, it has a very rigid structure. So if you are trying to stack one saturated fatty acid upon another, it forms a compact arrangement, which is why they are solid at room temperature. Okay. Now moving on to the unsaturated fatty acid, again there are different types, ALA, EPA, DHA, all these come under the unsaturated fatty acids. For an example, I have taken linoleic acid here, C18H32O2. And if you look at this here, there is one double bond here, then there is another carbon double bond here. So unsaturated fatty acids have one or more double bonds in their structure. Now what happens is that these double bonds create a kink or bend in the structure of the compound. So there is a double bond here, and then there is a kink here, and then there is another double bond, there is another kink here. Because of the formation of these kinks, if you are trying to stack one unsaturated fatty acid upon another, it doesn't form a very compact arrangement. Let's see, for example, I am taking a fat here, like with a glycerol head. Supposing there is a kink here, then we are trying to stack another unsaturated fatty acid, so there is a kink here. So if you notice, it's not a very compact arrangement, right? That's why they are liquid at room temperature. Now when there is only one double bond, it's a monounsaturated fatty acid. When there are more than one double bond, it is a polyunsaturated fatty acid. Now there are also something called as omega-3, 6 and 9. So where do they come into the picture is that omega-3, 6 and 9, these numberings are given based on the position of the first double bond. And always remember, when we are giving the numbers, we have to start from the CH3 end, not from the COOH end. So here is the methyl group. So if we are counting the first double bond, not the second or the third double bonds. Now here is the first double bond. So 1, 2, 3, 4, 5, 6. The double bond is present in the 6th carbon atom, which makes linoleic acid and omega-6 fatty acid. Now if the double bond is present next to the third carbon atom, that would be an omega-3 fatty acid. So based on the number of carbon atom holding the first double bond, omega-3, 6 and 9 fatty acids are classified, and always remember numbering has to start from the methyl group, CH3 group, not from the COOH group. Now finally there is one more thing called essential fatty acids and non-essential fatty acids. So as the name suggests, essential fatty acids meaning our body cannot synthesize those. It has to be given through the diet. Those are called essential fatty acids. Non-essential fatty acids can be synthesized by the body using anything else, using amino acids, carbohydrates, they can be synthesized. So alpha linolenic acid, eicosapentaenoic pentaenoic acid, docosahexaenoic acid, all these are omega-3 fatty acids. Gamma linolenic acid, arachidonic acid and linoleic acid, all these are omega-6 fatty acids. EPA and DHA are mainly found in fish oils. So when it comes to vegetarians and vegans, they can get their omega-3 through algal supplements, which are also a good source of EPA and DHA. Our bodies can convert some of the ALA into EPA and DHA, but it's not a very efficient process. Body cannot synthesize as much EPA and DHA as required from ALA. So these are the structures of saturated and unsaturated fatty acids. Now once we understand this, it will be easier to understand how a triglyceride molecule is formed with a glycerol backbone and fatty acid tails attached to it. Now as we know, glycerol is CH2OH, CHOH and CH2OH, and we are taking 3 fatty acid molecules here, right? Now this R represents a hydrocarbon chain. This represents the COOH. Now these two undergo a process called as esterification, wherein an alcohol and an acid react together to form an ester bond with the elimination of 3 water molecules. Now what happens here is this OH from the fatty acid and this hydrogen atom from the glycerol are eliminated as a water molecule. So there would be 3 water molecules that are eliminated here, and as they are eliminated, an ester bond is formed here. So a triglyceride molecule is formed from 1 glycerol and 3 fatty acids. With the elimination of 3 water molecules, an ester bond is formed and a triglyceride is formed here. Now these fatty acid molecules, they can be either saturated or unsaturated, or they can be a mixture of both. Now when we are talking about saturated fats, not saturated fatty acids, saturated fatty acids as we know include lauric acid, myristic acid and all that. Now saturated fats, what they mean is that it is a triglyceride molecule basically having glycerol and supposing 3 saturated fatty acids here, then that would be a saturated fat. Now for example, butter, cheese, coconut oil are all coming under the saturated fats, right? Now you might be wondering, saturated fats should be solid, coconut oil is sometimes liquid. So this is because of the temperature. In tropical countries where the temperature is quite hot, it's liquid at room temperature, but in colder countries it's solid. So that's why they are coming under the saturated fats. Now if you ask whether coconut oil is completely made up of saturated fatty acids, no, they are not. One of the most important saturated fats in coconut oil is the lauric acid, but 80 to 90% it has saturated fatty acids, and 6 to 8% it also contains unsaturated fatty acids. Linoleic acid is the unsaturated fatty acid that is present in coconut oil. So it doesn't have to be completely made up of saturated fatty acids. Unsaturated fatty acids include olive oil, soybean oil, nuts like flax seeds, walnuts are all high in unsaturated fats. So basically the difference between saturated fatty acids or unsaturated fatty acids and saturated fats is that when we are saying fatty acid, we are only mentioning the fatty acid. When we are talking about the fats itself here, it's a triglyceride molecule with a glycerol head and fatty acid molecules. So that's the difference between fatty acids and fats. I hope the difference between different types of fatty acids is clear. If there are any doubts, feel free to drop it in the comments below. Thank you.